So looking up at the warm-up, we have some square root equations that we have to solve. Remember that to undo squaring that x, we're going to square root each side. So when I square root each side of the first one, I get x equaling positive or negative 6. It is an equation, so you do need that positive negative symbol. Second one, square root each side, and x equals positive or negative 12. 3 I'm going to write down here a little bit better. We have to get rid of the 5 first by dividing each side by 5. And I get x squared equaling 4. Square root, and you get positive negative 2. Again, I cannot stress enough the importance of having the positive negative symbols there. They have to be there. Today we're going to be looking at cube roots. If you remember, square roots was when we took a number and multiplied it times itself. 4 is a perfect square because of 2 times 2. 9 is a perfect square because of 3 times 3. Well, cube means 3 of something. So 3 of the same number multiplied together are your cube roots. So just like we did with square roots, we have a chart. We're going to do 1 cubed, which is 1. This time we're going to do the cube root of 1, which takes us back to 1. The cube root, that's a little 3 in there. It's a little hard to make 3's that small on here, but that's a little 3. Okay. And we have to have the 3 there because we're not square rooting it anymore. We're not trying to find what number times itself gives us that answer. We're trying to find what 3 numbers times themselves gave us this answer. Whoop, back to my pen. So 2 cubed gives me 8. And the cube root of 8 is 2. 3 cubed is 27. And the cube root of 27 is 3. 4 cubed is 64. And the cube root of 64 is 4. 5 cubed is 125. The cube root of 125 is 5. 6 cubed is 216. The cube root of 216 is 6. 7 cubed is 343. And the cube root of 343 is 7. You are only expected to know 1 through 5. You need to know your perfect cubes, 1, 8, 27, 64, and 125. If I ask you what is the cube root of 125, you need to be able to tell me 5 without your calculator. If I ask you what is the cube root of 27, I expect you to be able to tell me that it's 3 without the use of your calculator. I'm only asking for 5. So now let's review the 5. Cube root of 8. Again, we need to be able to do this without the calculator. Is 2. Cube root of 1 is 1. Cube root of 64 is 4. Cube root of 125 is 5. And the cube root of 27 is 3. So now we're going to look a little bit at evaluating some expressions. So a wooden block is a cube. Okay? And volume, if you remember, is length times width times height. But because it's a cube, my length, my width, and my height, they're all going to be the same. So instead of writing length times width times height, we can actually just go x cubed. We don't know what they are, but we do know they're all going to be the same. And we know the total is 125. To undo cubing something, we're going to cube root. So we're going to cube root each side. And the cube root of 125, we should know off the top of our head, is 5 centimeters. Now we want to paint the front face of the block. Okay, just the one little square on the front, not all of it. So now we're finding area. Well, if one side is 5, area is length times width. So 5 times 5 should give us 25. And it's going to be centimeters squared because we're doing area, and area gets square units. Same sort of problem. I'd like you to try this one on your own. So we have our fish tank that's the shape of a cube. The volume again, all my sides are going to be the same. So I'm going to cube root each side. You have to remember to put the 3 with the cube root symbol. And you get that x is 3 inches. Each side of the fish tank is 3 inches. It's a pretty small fish tank. If we wanted to place a cover on top of the fish tank, okay, so just a flat piece of wood just to place on top of the fish tank, that would be area for the lid. So that would be 3 times 3, or 9 inches squared. How big of an area would I need to cover? We've already talked about cube root equations when we were doing the evaluating problems. But here they are more mathematically, not represented in the word problems. Again, to get rid of y cubed, you're going to cube root each. So that's it for this lesson. It is a rather short lesson on cube roots, but an important one nonetheless. You should have the worksheet in front of you. If you don't, you should be able to access it from my webpage.